Hello, my name is ARNAV CHATTERJEE from EPH third year, and I'll be presenting my LED matrix interfacing project for this lab. And instead of just displaying static characters, I've decided to essentially recreate a multi-frame hyper beam animation of sorts, which would be it's uh, kind of like from Dragon Ball Z, which is where I got the inspiration. So we're going to be using the 8285 microprocessor, and the peripheral unit would be the 8255 PPI. So to start with, these are just how the components are connected. As you can see, the 8285 microprocessor communicates with the LED matrix through the peripheral interface. Port A, as you can see, pushes the row pixel data, and port B the column pixel, as we multiplex to choose exactly which LEDs to control, and the control port configures it. Uh, so system clock is also part of the thing at least. So now animating on the sketch requires a specific sequence. We initialize the 8255 load our first frame pointer, then we scan through the columns to draw the image, and then dynamically advance to the next frame, as you can see here. By cycling through we have six preloaded frames that we had to previously already add to the 8055. We can trick the eye into seeing like a smooth moving image. And for that, we have to think about the delay, which we'll talk about in just a second. So now we can see the logic applied, right? So this is the flow chart of the logic. The outer loop, I'm not sure if it's very visible, but essentially the outer loop is with initting the 8255 right here. Then we have a master animation loop that's right after that, starts next. And then we have to figure out the frame hold duration between each frames to make sure that it looks like a smooth animation. We have a row scan setup over here first before, because we don't have columns. After that, we have a matrix multiplexing, which is combining the port A for the row scan and the port B for the column scan. Then we actually see set delays, the short delays, so that the LEDs stay, lit for the human eye. And then after passing through this entire loop, through the outermost loop, which is the frame hold duration loop, we advance to the next frame. And then once we're done with all the frames, we can jump back into the master animation loop. So the entire loop will repeat again. Right. So that is the fundamental process that we have used here for this uh, animation. So now we can look at the code, right? We start at address 2000 by throwing 80 into the accumulator and outputting it into port 03 to initialize our 8255. Then we load register D with 06 to account for our 6 frames. And then finally we can point our HL, which is the main register pair. So HL register pair to 2050, which is the memory address where our first frame's pixel data is going to start, right? So it's a Goku animation. Yeah. We'll look at the animation as well, how we made the hair. So next, right? So the frame duration and the multiplexing setup. So this is where we control the speed of the animation, right? The delay counter, as you can see. By loading the register E with 60 hex, we can significantly lower the delay time over here, and this speeds up the scan rate and gives the energy beam like a really fast and chaotic flicker. We'll see in the video as well how it first we wanted to make sure that it flickers from thin to larger, making the explosion animation. Uh, so we'll see how, so this, it's a lot smoother when we have a delay counter of 60. Right. We also load register B with FE, which is the binary of 111111110, which is the active low. Because it's an active low, you want to put on all of them. And this activates, this is our, to activate our active low column sector that is starting on column 1, which is how we start the frame. Now this is the core loop and the lighting of the LEDs, right? This was the master loop that we showed in the block diagram. So here is the core code, right? We grab the row data from the memory and send it to the port 00. You can see out 00. Then we start our column sector from register B and send it to port 01. Right. Immediately after, we hit it with an RLC instruction to rotate the active bit left, shifting us to the next column for the next pass. And we do this 8 times per frame. That's why 0, 7 is like 027, right? And that's what makes sure that the timing of the frame is accurate for the human eye. And this is where the persistent vision comes to play. So if the processor just blasts through all those columns with no delay, right, which we had first set up, the LEDs would cycle too fast to and would basically appear completely invisible. Right, that's why we drop that tiny loop using the hex value 40, right, to force the processor to waste a fraction of a millisecond, and this creates that persistence of vision for us to actually see the animation taking place. Right, otherwise it would just go too fast. Uh, and this allows yeah, I mean, yeah, this has nothing to do with the delay that we have to place between each frames. This is to make sure that the frame is visible, just to keep that clear, right? um, Next, so to make the animation rather than a static image now, we also need the frame to move from one frame to the other, right? And we don't want to make that just look too dicey. So every time a frame finishes its display duration, we can take the memory pointer and add 08 to it over here. And since the matrix is 8 rows tall, right, 8 into 8 LED matrix, adding 8 bytes shifts us perfectly to the start of the next frame's data. Right, so once all 6 frames play, the program can just loop back indefinitely, right, at the end of the um, animation. So we can keep seeing the same explosion again and again until we obviously reset the animation. So now let's talk about the how we made it. Right, we had to make sure that there's a front moving stance. As we'll see in the video, stance is sideways. It's already left shifted. Character has to be left shifted, and we want to make it such that there's a blast outward into the right. Right. So we had to pack the character's body and head tightly on the left with the F7 and 7F codes. We have F7 and the 7F, and that's the head. And then down with the feet, we have the 30 to 1C, which um, moves sideways, which shows the legs, right? Uh, and then we have the hardware demonstration, and yeah, thank you. For my innovation project on the LED matrix, I have simulated a character from Dragon Ball Z, Goku's Hyper. So the bottom is the feet as a stick figure, and on the top is the head, and he shoots the beam outward and explodes. Yes, thank you.